Yeah, good evening all. So in the last class, we had some introductory session of PySpark, Spark with Python. So before I start, can anyone please confirm whether my voice is clear, whether the screen is visible or not? Yes. Yeah. Is my screen visible to all? Is my voice audible to all? Can anyone please confirm me once? Mhm. So in the last class, we have discussed, yes, thank you. I've got enough confirmation. Fine. What is Apache Spark? Why PySpark? Need for PySpark? PySpark features and real life usage. Just I'll take 2 minutes what we discussed in the last class. So Apache Spark was developed in the year 2009 by Matei Zaharia in AMP Lab. It was open sourced in the year 2010. It was donated to Apache Software Foundation in the year 2013. Mm. So Spark, if I would define Spark in 5 lines, it's an open source distributed cluster computing framework. Distributed cluster computing framework with in-memory computation feature in parallel processor style used for large-scale data processing. It's a general engine for big data analysis computations, right? That's got very high speed. It's a very high speed processing execution model which process huge data in quick time. Spark is 100 times faster than normal disk processing. Why PySpark, right? Yes. PySpark is the Python API to use Spark. It is an open source and it's a lightning fast technology that is designed for fast computation. It's a very demanding tool among data engineers to work with bigger data sets. It is used for running distributed SQL, creating data pipelines, ingesting data into database, running ML algorithms, and working with the graphs and data streams. Yes, PySpark means Python plus Spark, means it's a Python API to use Spark. See, huge amount of data is getting generated. The data contains hidden patterns, unknown corrections, market trends, and customer preferences. So we need to extract the required data. It's necessary to extract valuable information from the raw data. We require a more efficient tool. We require a more efficient tool to perform different types of operations on this big data. There are various tools to perform this. There are various tools to perform this, right? Multiple tasks on this huge data, but these tools are not so appealing. So we require some scalable tools which can crack this big data and gain benefit from it. So PySpark is such a kind. So combining Python and Spark would be the very efficient for the world of big data. So that's why Apache Spark community, they came up with a tool called PySpark, the Python API to use Spark. Python mostly implemented in Python language and Scala language. You see today like Python is mostly preferred because it's dynamic typed and it's interpreted, but Scala is statically typed. Python has a huge community. It supports around 89,300 modules. Scala community is smaller. Scala community is smaller, right? Python contains powerful libraries for data science, for graphs, for streaming. Libraries of Scala are less compared to Python. Python is slower compared with Scala. Scala is faster than Python. Okay. So one thing is Python is slower, but Scala is faster. That's the only advantage, but remaining all right. It has got thousands of modules. It has got powerful libraries, mostly preferred today, right? Python features, if we say Mainly in-memory computation, storing and processing both happening in the memory level, right? Yes. Lazy evoluted and active evolution, lazy evolution means right. Lazy evolution only is better because executing the data flow means the flow execution happens only when you perform some kind of action. Until then, they won't get executed. Active evolution means immediately whenever you define executing, that is what active evolution. Lazy evolution, nothing but on demand you are executing the flow. Partitioning. Spark data is divided into partitions and are distributed across multiple RAMs of multiple worker nodes. Means if data is distributed and it's partitioned and distributed, persistence means already executed transformation output. No need to re-execute. We can already execute a transformation. We will be reusing. Immutability. Spark data objects are immutable. Means the original data object is not getting modified. Spark has powerful fault tolerance model. I was saying motivation towards the Spark. If you see the speed of Spark as compared with other things, right? Yahoo has taken a table of 100 TB consisting of 1024 columns. The task was sorting based on 16 columns. Time taken by Oracle. It has taken around 3.5 days. MySQL has taken around 6 days. These have taken days of time, right, to handle this. And this Teradata is specialized database used for data warehouse. It has just taken 4.5 hours. Netezza has taken 3 hours. Hadoop just taken 3.4 minutes. Hadoop has just taken 3.4 minutes. Spark is 100 times faster than Hadoop. Spark is for batch applications. Spark is for batch applications, not for online applications. Spark is not for online applications, means like a request, whenever you give a request, getting response, not for that kind. Batch millions and trillions of records or transactions for handling that, for processing it. It's 100 times faster than Hadoop. Hadoop is, can you see, Hadoop has taken minutes of time as compared with this days and of time. This have taken hours of time. This have taken, but Spark is 100 times faster than Hadoop. Then see the speed of Spark as compared with this. Spark can be coded with multiple languages: Python, Scala, Java, and R language. So Python and Scala are mostly preferred. Java and R language, they are very less used, but it is providing multi-language support. Spark data objects, we call it as RTD, or data frames. We call this as resilient distributed data sets and data frames, we say. So there were two, Tej and Spark. If we are comparing Spark and Tej, right? Yes, both follows DAG model, but Tej doesn't support in-memory. So as compared to Tej, Spark has got very high speed. Other in-memory computation systems, HANA is there. HANA and Spark, if you see, both follows in-memory, but HANA is not distributed, but Spark is distributed. Spark is mainly designed for batch applications, iterative algorithms, interactive queries, and for streaming. See, mainly if we talk about the Spark data objects, if I discuss about Spark data objects, RTD, resilient distributed data sets. Resilient distributed data sets. How this RTD is created means RTD1 using a Spark context dot text file. There is a file path. If you have got a file, if you have got a big file, huge file, right? The file path you provide using Spark context, then RTD1. On this RTD1, if you want to filter something, if you perform some filtering operation, RTD2 is created. RTD2 is created. On this RTD2, any transformation mapping something, RTD3 is created. On this RTD3, on RTD3, right? Yes, RTD3. RTD3 dot group by RTD4. Finally, RTD4 dot action, like some collect is an action. Whenever you say some action, then from RTD1 to RTD4, it will execute and RTD4 output will be collected by the client. Means this is your flow. RTD1, RTD2, RTD3, RTD4. This is your data flow. Means where these 4 RTDs, everyone try to unmute and try to respond. I want the sessions to be interactive. Whatever understanding you had. 4 RTDs are there. Each one is a big data object. Where these RTDs are stored? Where these RTDs are stored? We are saying in-memory computation, right? We are saying it as in-memory computation means they are getting stored in the memory that is in the RAM and they are processed in the memory that processed within the RAM. RTDs, they'll be stored in the RAM and processed in the RAM, right? But each RTD is a bigger data value. All these RTDs cannot be loaded into RAM simultaneously. 2 RTDs never execute in parallel. Spark data objects means they will be parallel processing will be there. But how come RTD1 think that like 10 GB file, 10 GB file, it will be splitted into smaller parts. Spark data object will be divided into smaller parts like this. Each part is stored in each RAM1, RAM2, RAM3, RAM4 in this way. System 1, System 2, System 3. So in multiple systems, that is in multiple RAMs of multiple systems, it is getting stored and processed parallel. Means 2 things you can see, distributed, parallel processing, in-memory computing. Once this RTD1 computed, processed, the output of this is given as input to this. The output of 1 will be the input to this. And RTD2 also, it will be divided, stored across multiple systems. Once RTD2 computation is completed, then RTD1 in its partition, everything gets removed from the RAM. Means if you go forward, RTD by RTD, they are getting loaded into the RAM. They are getting loaded into the RAM. Once RTD2 is computed, its output is taken as input by RTD3. Sorry. Once RTD3 is computed, RTD2 and its partitions gets removed from the RAM. Understand here. When RTD4 is ready and computed, RTD3 and its partition gets removed. Now, finally, once this RTD4 output is collected by the client, then this RTD4 also gets removed from the RAM. This RTD4 also gets removed from the RAM. Yes. Now, no RTD in the RAM. Now, no RTD in the RAM. You can trigger the next data flow. But here, I'll just explain with an example now to make you understand about one more important feature of Spark, persistence. One more important feature of Spark, that is what? Persistence. Persistence means already executed transformation output we will be reusing. R1, R2, R3, R4. From here, R5. R1, R2, R3, R4, R5, R6, R7, R8, R9, R10. This flow 1 is R1, R2, R3, R4, R5, R8. Flow 2 R1, R2, R3, R4, R6, R9. Flow 3 R2, R3, R4. This is the flow 1. If I want to execute this flow 1, if I execute this flow 1, R8 dot collect, R8 dot collect. Whenever you say any kind of action, then this from R1 to R8, the entire flow executes. If you perform an action only, otherwise it won't execute. So starting from R1, R2, just see this flow, R3, R4, R5, R8. So how this is when R2 is loaded and computed, R1 and its partition gets removed. When R3 is loaded and computed, this R2 gets removed. When this R4 loaded and computed, means in this way, how the computation is going to happen. Finally, the output is collected. This also gets removed. Now, no RTD in the RAM because all these multiple RTDs, if they get loaded into the RAM, there won't be any space available for the upcoming RTD to be get loaded. So flow 2, if we observe this flow 2, R9 dot collect, if we say collect, this is one of the action. These are some of the actions. If I say R9 dot collect means from R1 to R9, the flow executes. In this way, the flow executes. Once it's loaded and computed, the previous one gets removed. When this is loaded and computed, the previous one gets removed. This gets removed. When this is loaded and computed, this gets removed. This is going to get removed from that. Now, once the output is collected, this R9 also removed from the RAM. No RTDs in the RAM. Flow 3, this flow 2, flow 3, R10 dot collect. The flow will start from R1, R2, R3, R4, R7, R10. So whenever the next flow is ready, the previous one gets removed. When this is ready, this gets removed. This gets removed. Gets removed. When this is ready, this is going to get removed. Finally, when the output is collected, this is ours. But here, every time the flow is executing from the beginning, even though the first 4 steps are common, even though the first 4 steps are common, even though the first 4 steps are common, okay, every time it is re-executing from the beginning. The flow is re-executing from the beginning, even though the first 4 steps are common. So what you do, generally the persistence feature plays a vital role here. So the one which is mostly used by multiple flows, persist it, R4 dot persist, R4 dot persist. R4 dot persist, whenever you say R4 dot persist, yes, it will be available in the RAM and it won't get removed from the RAM, so that it will give output to the many different flows. It gives us output to the many different flows. This is your flow R1. This is your diagram R3, R4, R5, R6, R7. This is your flow. See, first I want to execute the flow. This is persisted. Persist. How will you say persist? R4 dot persist. You say R4 dot persist. Whenever you want to execute the flow 1, you will say R8. If you want the collect this output of this R8, R8 dot collect, you will say. First time the entire flow executes R1, R2, R3, R4, R5, R8. Once this loaded, computed, whenever this loaded and computed, the output of this is given as input to this. When this is ready and computed, this gets removed. When this is loaded and computed, this gets removed. The output of one will be the input to the next. So this is a data flow. But R3 loaded, computed, and persisted. R3 loaded, computed, persisted. Means whenever R4 is ready and computed, R3 won't be removed from the, sorry, not R3, R4 is persisted, right? Yes. R4 loaded, computed, and here R4 is persisted. This R3 gets removed. But R4 loaded, computed, persisted. When R5 is ready and computed, R4 won't be removed. When R8 ready, loaded, computed, then it will be removed. When the output is collected by the client, then this also gets removed. R3 available in the RAM. But flow 2, if you observe this flow 2, whenever you say R9 dot collector, understand everyone? R9 dot collector. Whenever we say R9 dot collect, immediately it will check for R9. The input is R8. Is R8 available in the RAM? No. Next, it will check for R8. What is the input? R4. R4 available in the RAM. R4 available in the RAM. So the flow starts from R4. So no need to execute from the starting. The flow is from R4, R8, R9, sorry, R6. This is your flow. Don't need to execute from the starting. No need to execute from the starting. This is flow 2. Flow 3 also the same. No need to re-execute from that. Whenever you persist anything, the advantage of persist means making it available in the RAM even though the next RTD is ready, so that it can provide its output to the many different flows. R10 dot collector. Whenever you say R10 dot collector, R10 input is R7. R7 input is R4. R7 input is R4. R4 available in the RAM, right? So the flow is from R4 to R7 to R10. No need to execute from the beginning. No need to execute from the beginning. Yes. You can start from R4, R7, R10. No need to execute from the beginning from R4 to R7 to R10. Okay. So what is your observation here? Whenever any RTD is persisted, so in the all the three cases, so here R4 available in the RAM, R4 available in the RAM, here also R4 available in the RAM. So whenever R6 ready, R4 won't be removed. When R9, this gets removed. When the output is collected, this also gets removed. When R10 is ready, this gets removed. When the output is collected, this also gets removed. In all the cases, R4 will be available in the RAM. No, all the remaining RTDs will be removed from the RAM. Once your execution is completed, when the flows are executed, right? Once, if you want to, now R4 is not required, means you can unpersist. You can unpersist. R4 dot unpersist. Whenever you say R4 dot unpersist, immediately the RTD will be removed from the RAM. Anytime if you have persisted in a RTD, how will you unpersist it? Immediately by saying R4 dot unpersist. Unpersist happens immediately, but persist won't happen immediately. If you say R4 dot persist means immediately it won't load R4 and persist it. Means before R4, three other RTDs has to be loaded. First they has to get loaded. When it comes to R4, when R4 is loading, computed, now it will be persisted. Unpersist happens immediately, but persist won't happen immediately. Persist happens during the flow execution. Whenever R4 you want to persist, or if you want R15 to persist, whenever R15, when it will be persisted, after 14 RTDs got loaded, whenever you are loading R15, at that time only it can persist it, but unpersist happens immediately. So if you see some questions here. So that interview based questions also I'll be discussing during the session. First, what is lazy evolution in Spark? What is lazy evolution in Spark? Anyone? I want the sessions to be interactive, whether answers are correct or wrong, keep responding. What is lazy evolution in Spark? Means we data flow, executing the data flow on demand by providing some action. Whenever action is done, then only the data flow will be executed. Until then, it won't execute. What is in-memory computation? What is in-memory computation, right? Storing and processing happening both within the memory level. Storing the data and processing the data, right? At the memory level, RAM level. Which RTD to be persisted? Which RTD to be persisted? The RTD whose output is commonly used by multiple flows, that RTD we will persist. Different ways of persisting an RTD. Two ways. RTD.persist is one way, and second way is RTD.catchy. RTD.persist and RTD.catchy. Two ways to persist. RTD.persist just now I discussed, right? But RTD.catchy also similar to persist only. But first option, persist option, you can persist in memory, you can persist in disk. But catchy can only persist in memory only. Disk it cannot. In disk it cannot. And many other options. First two option, RT.persist takes many options are there. I'll be discussing what are the various options. But second one, RTD.cache, it can take only one option in memory only. We can just persist in memory only. Different ways to unpersist RTD. Three ways. Forcefully unpersisting by saying RTD.unpersist. Second way, whenever the server shutdowns, whenever the server shutdown, and whenever the session is closed. Whenever the session closed, it will be unpersist. Whenever server shutdowns, whenever RTD.unpersist. The different ways. What are the different ways where RTD gets removed from the RAM? Two ways. Whenever the next RTD is ready, previous RTD gets removed. Previous RTD gets removed from the RAM. Whenever the entire flow is executed, the last RTD gets removed. Next, explain fault tolerant model in Spark. Fault tolerant. I'll come back. I'll explain now. Explain fault tolerant model in Spark. Um, what is persistence in Spark? And what is and its advantages? Just now I discussed, right? Persistence. If you persist in RTD, right, it will be available in the RAM so that it will give output to the different flows. Otherwise, every time you need to re-execute from the beginning. Every time you need to re-execute from the beginning. If you want to understand much better about this persistence, if you take a very big flow, you will understand it. Check it. If you got R1, R2, R3, so on up to R50. 50. From here onwards, you can say like R70, R80, R90. First time compulsory, this flow has to be executed first flow. Then if you persist this R50 second flow onwards, they can make use from R50 to R80. No need to around 50 steps got decreased. No need to execute the first 50 steps for the second flow. Third flow also. Directly it can execute from R50. Directly it can execute from R50 to R80, R50 to R90. That is what the persistence advantage. No need to re-execute from the beginning. Already from the persisted RTD onwards, you can execute the flow. Explain fault tolerant model in Spark. Explain fault tolerant. And what are the various persistence options? I'll come back to this. What are the various persistence options means? Memory only. Means if you want only in the memory only, you can, in memory only, you can persist it. Memory underscore SCR underscore only. What do you mean by generally RTD will be persisted object type in object format, right? But what do you mean by serialization? What do you mean by serialization? In a simple way, serialization means converting object format to byte format. What advantage you will get if I convert to byte format means object format occupies more space, byte formats very less space, 50% less occupancy. Deserialization, again converting a byte to object, byte format to object format. Here, why you need to convert to object format? If you want to execute the RTD, it should be in object format. So here, memory only, memory underscore serialized format. What is the advantage of memory only means? High speed. Why high speed? Because already it is in object format, no need to deserialize it. But what is the drawback of it? Object format occupies more space. Byte format occupies less space. But what is the advantage of serialized memory underscore serialized? It will be serialized means it will be in byte format, less space occupancy. But what is the drawback here in serialized format? Again, if you want to execute it, again byte format has to be this has to be deserialized from byte to object. So both has got advantage and disadvantage. Yes, advantage here, high speed, no need to deserialize. Here, disadvantages, we need to deserialize. Here it has got high speed, here has got low space. That is advantage. Disadvantages, more space occupants. This is less speed. Next, you can also, for example, you are persisting in RTD. Your RAM size is 8 GB, your RTD size also 8 GB. Exactly, it can fit. But RAM is busy executing other RTDs, so only 5 GB available. Then the RTD cannot fit in the RAM. In that case, disk only. If you want to only in disk, you can say disk only. Otherwise, disk underscore serialized only. These two, if we compare these two, right, both will be persisted in the disk. When you go for disk, then if you have not got the sufficient memory, then it will be always in the disk. Always persistence happens in the disk. And what is the difference between disk and disk underscore SCR? The same whatever I discussed for the first two. In the disk only, the advantage is high speed. No need of deserializing because already it is in object format. Disk underscore SCR means what? We need to, okay, disk underscore SCR, it will be in byte format. It will be in byte format, this will be in object format. Object format, more space. This byte format, less space. That is, but what is the advantage of disk only means high speed, no need to deserialize. One more option. Disk and memory only. See, these 5 options are there. I said 2 ways to persist, right? This persist will take all these 5 options, but catchy will take only the first option. This catchy will take only the first option. If you got enough memory, you can go for memory. If it doesn't have memory, go for disk. If you are not sure about memory and disk, it is memory and disk only. Memory and disk only. If memory available, in the memory. If memory available, you persist in the memory. If not available, it will be persistent in disk. What happens in this case means it is not going to get failed. Your job is not going to be failed. If memory available in the memory, it will persist. If not available, it will persist in the disk. Yes. If you talk about the fault tolerant model in Spark, fault tolerant model in Spark. See, just observe this fault tolerant model in Spark. This is R1, RTD1 divided into multiple partitions P1, P2, P3. Data in system 1, system 2, system 3. RTD2 is divided into 3 partitions. S1, S2, S3. Whenever this from R1, R2 data is loaded, but suddenly this system is down, S3. Then what happens until this computation is finished? This is not removed, right? Until this R2 computation is finished, it is R1 is not removed. So it will deallocate all the P1, P2, P3 partitions and again takes the output of it as input, and it will store in 3 different systems other than this, other than the system which is down, and again it will be loaded. This case 1. In case 2, R1 is there, R2 is there. This is current one, this previous one. It is stored in three systems. Stored in three systems. Still it is not stored, but whenever you are collecting the output as input, suddenly this is down. While collecting the output of R1, the system 3 is down. Then what happens in this case means it has to re-execute. It has to take the input from the file again, recompute R1, again recompute R2. So in these cases, in one way it is good, one way it is bad, right? Yes, bad means we are re-executing them, already executed. Good means we are making the flow to execute. Yes, and that's right. Okay. So these are the questions. What is lazy evolution? What is in-memory computing? Which RTD to be persisted? Different ways of persisting. Different ways of unpersisting. What are the different ways of where RTD gets removed from the RAM? What explain fault tolerant model? What is persistence in Spark and its advantages? What are the various persist options? These are the various persist options, right? Yes. So yes, I'll be explaining about these things practically in the next. What are the different ways to create an RTDs? Last one more query. What are the different ways to create an RTD? This will be our next discussion. Different ways, three ways are there. What are the different ways to create a RTD? Three ways are there. So in every session, I'll be discussing around some 10 questions where you can see it like the interview based on each topic. You'll understand much better. I want the sessions to be more interactive, mostly from next week. We'll be starting with the practical part. So I'll forward you the software to your Google Drive. You can just download from there. And next Saturday onwards, we'll be going with these things practically. So next Saturday, the link will be changing. It's a weekend batch. Saturday for 2.5 hours. Saturday also like for 2 hours will be taking. Next Saturday, the link will be changed. So you are supposed to get enrolled to get the link, right? So you can see in the chart, message is given by this online team. Yes. 1 second. And so you'll, yeah. So you will be getting the videos to your Google Drive. Even if you miss any session, you'll be having the session videos. Each and every session video is recorded. You'll be getting the session of it. Clear soft copy of these notes will be provided. A WhatsApp group will be created, will be added to the group, but you can have direct interaction with me. Assignments and tasks to work. Like even if you want to do the practicals parallel along with me, you can do hands-on practical sessions. And if we can see the course content in brief, in depth, I'll be discussing about it. So PySpark real life sessions, Spark context, PySpark RTD computations, RTD steps in RTD computations, persistence feature, memory only, disk only, and PySpark core computations, right? How to increase the number of partitions, Spark groupings and aggregations, various inbuilt actions and transformations one by one with many working examples. And coming to this data frames, which are mostly used today, SQL data frames, right? Data frame, creating empty data frame, different functions in each data frame, API functions, one by one with many working examples, PySpark SQL functions, aggregate functions, window functions, date and timestamp, PySpark built-in functions. Various PySpark built-in functions one by one, right? And external sources, Spark and Hive integration, Spark and MySQL integration, working with CSV, JSON. Yes, handling nulls, deployment modes, local mode, cluster mode, PySpark application, states and task drivers and executor, building Spark applications, performance tuning, and PySpark streaming concepts, integration with Kafka, and PySpark ML lib, right? This is what. So in brief, in depth, I'll be discussing about all these things, right? And you can also see in the chart, right? The contact details of the online team. A big message is given now, right? The contact details of this online team, the payment details, their contact details, and they're given a note, right? If you got enrolled, right, don't forget to share the payment receipt to that mail ID that is given, DURGASOFT online training. Then only they forward you the link, right? Their account details, the Paytm or this Google Pay or Phone Pay details they have given, right? If anyone missed yesterday session, the yesterday session video and course content details is provided, right? So I'll show you how to run in different environments. So within this and how to run different environments, even like in Jupyter Notebook, in Databricks environment, and different other environments, right? Any queries you got from next week onwards, will we go with the 2-hour sessions? Saturday for 2 hours, Sunday for 2 hours. Later, if possible, I'll extend for half an hour or more. Any queries you got, anyone? Okay, fine. I'm done with the queries. If there are no other queries, I'm signing off for now. Meet you next Saturday, more discussion, continuation of this. So get enrolled for getting the link, the videos, notes. Fine. Thank you all for your time. Thank you.